In this video, we're going to talk about solving literal equations. Are you wondering what literal equations are? Well, they are equations that contain more than one variable. We call these literal equations formulas, and we can use formulas to help us solve application problems. In our first example, you might recognize V equals LWH. That's volume equals length times width times height. And the way this literal equation is given, it is solving for volume. We would like to rearrange this and solve for one of the different variables, and that would be for height. So in order to do this, we are thinking about the properties of equality that we talked about in our last video. So think about how height is being connected to the other variables, L and W. If they're all written in a row this way with no symbols in between, that means they are all being multiplied together. So to undo multiplication, we're going to divide. So if we have V equals L times W times H, to eliminate length and width, we're going to divide by length and width. Well, that means that both sides of the equation must be divided by the exact same thing. So we end up reducing length and width on the right, and notice we're left with the variable we wanted. So volume divided by length times width is equal to the height. So in order to rearrange these formulas or literal equations, we're simply applying the properties of equality. In example 2, you might recognize 4x minus 3y equals 10 as the equation of a straight line. We want to solve for y. So when we do that, we're actually transforming the standard form equation into the slope-intercept form of the line. So let's find y. Y is written right next to a negative 3. That means it's being multiplied by a negative 3. And then we also have a positive 4x, so that means it's being increased by 4x. So we've identified two operations that need to be undone. So I'll take away 4x from each side of the equation first. That means 4x is eliminated from one side and collected on the other. I have negative 3y now equals negative 4x plus 10. The final step is to isolate y. It's being connected to the negative 3 with multiplication, so I need to divide that term by negative 3. That means every term in the equation is going to be divided by negative 3. When I simplify, I am left with the variable we are trying to solve for. Y equals negative divided by negative will simplify as positive 4/3 x. Positive 10 divided by negative 3 would be a negative 10/3. And this is our answer. We have rearranged the given equation to solve it for the other variable. In example 3, we have A equals 1/2 times the quantity capital B plus lowercase b times h. Capital and lowercase b are two different variables, so do not combine those. We want to rearrange this formula or literal equation for capital B. So here's where it's located. So we have several things we'll need to take care of here. We've got parentheses, we've got a fraction, we've got multiplication. So it might be easiest to eliminate the fraction from the equation first. 1/2 is our fraction. Since 2 is the denominator, multiplying by 2 would eliminate that fraction. So both sides of the equation are going to be multiplied by 2. When that happens on the right, you can see how the fraction eliminates, and we're left with 2a now equals capital B plus B, quantity being multiplied by h. So I could take care of that distributing right now. H is multiplied by capital B to give us capital BH, and then h times the lowercase b. So that's BH. Again, identify which of these variables are we trying to solve for, and that's capital B. So what it looks like we need to do is undo any operations happening to capital B. That would be multiplication of h has to be undone, and addition of BH needs to be undone. So I'll start by subtracting BH from each side. That leaves me 2a minus bh. Those are not like terms, so I can't actually subtract them. I can only write down that expression of subtraction equals capital BH. So now we just have one step remaining. If we're trying to isolate capital B and it's multiplied by h, division of h will help us to eliminate h. So every term is divided by h. What we notice in the first term, 2a divided by h. There are no common variables there. So the 2a divided by h will remain. Next we have subtraction. Notice how h appears in both the numerator and denominator, so that actually reduces, and we're only subtracting lowercase b. On the right-hand side, h reduces, and we are left with capital B, and that's the variable we were trying to solve for. So here is our literal equation rewritten and solved for capital B. You might recognize example number 4. This is temperature conversion between Celsius and Fahrenheit. And here we have C is equal to 5/9 times the quantity of F minus 32. So we want to rearrange this literal equation to solve it for F, or Fahrenheit. Notice that we do have a fraction, and only one term in this equation has a fraction, so we'll use 9 as our lowest common denominator to clear the fraction. So if the lowest common denominator is equal to 9, we're going to multiply both sides of the equation by 9. So 9 times C would equal 9 times this fraction, 5/9, multiplied by the quantity F minus 32. So what happens is the 9's are going to reduce, leaving us 9C is equal to 5 times the quantity F minus 32. With parentheses, we'll need to clear by distributing 5 to each term in this quantity. So we'll end up with 9C equals 5F minus 5 times 32, and that's 160. What we are trying to do is isolate the term with F. So we can see two different operations are happening. F is being multiplied by 5, and it's going to be decreased by 160. So if we add 160 to each side of this equation, that will help us to get the term with F isolated. So adding 160 to both sides of the equation results in 9C plus 160 now equals 5F. So the only operation happening to F now is multiplication of 5. Division of 5 is the opposite, so every term in our literal equation will be divided by 5. So we can reduce, and we can clearly see that we are left with F equals something. So reduce wherever possible. 9 and 5 are not going to have a common factor, so that term remains 9/5 C. 160 divided by 5, that will be positive 32. So here we have an equivalent equation, but solved for a different variable from the original. So when you have C equals, it's helpful to use that formula if your input is Fahrenheit temperature. Whereas in this second equation, if you have Celsius, this would be the easier formula to use.